Good day everyone, our topic for today is all about heritability
in the narrow sense. Narrow sense heritability is defined as the fraction of phenotypic variance that can be attributed to variation in the additive effects of genes. Narrow sense heritability is always less than or equal to broad sense heritability. So in a simple words, it is measure of how well differences in people's genes account for differences in their traits. Traits can include characteristics such as height, eye color, and intelligence. A population of humans that are all 5'8" has extremely low phenotypic variance for height, while a population of humans that range from 4'2" to 7'6" has a high phenotypic variance for height. Humans vary widely in their height, meaning that height has a high phenotypic variance. So as you can see the picture, the right side, there are different types of phenotypic variance.
The heritabilities may vary for different traits in the same organism and for the same traits in different organisms. Now, since heritability is important plant breeding, why? Because it is a measure of a ratio of additive genetic variation to phenotypic variation in the given population for a given trait. As a rule, traits with greater heritability can be modified more easily by selection and breeding than traits with lower heritability. As you can see, there's a table to estimate of a narrow sense heritability of various characteristics in different species, such as cattle, chicken, Drosophila, melanogaster, and corn. Formula of narrow sense heritability. Narrow sense heritability is expressed mathematically as a ratio of additive genetic variance to total phenotypic variance. Here is the formula of narrow sense heritability. Narrow sense heritability equal additive genetic variance divided by total phenotypic variance. Total phenotypic variance can be further expressed as phenotypic variance equal total genetic variance plus environmental variance. How to calculate narrow sense heritability? In the population of beetles, the total variance of body width was 130. It was estimated the environmental variance was 35 and dominant genetic variance was 45. From this data, calculate heritability in a narrow sense. Broad sense heritability equals variance genetic divided by variance phenotypic. Today, I can use the narrow sense heritability formula. Narrow sense heritability equal variance additive divided by variance phenotypic. And to find the variant additive equal variance phenotypic minus variance environmental minus variance dominance. And also we can put the numbers. Variance phenotypic was 130 minus variance environmental is 35 minus variance dominance is 45 equals 50. And 50 is variance additive. And now I can just put again our formula. Narrow sense heritability is equals variance additive such as 50 divided by variance phenotypic such as 130. It equals 0.39. And if you need to answer the info sentence form, you just going to multiply 100 and the answer is 39. Conclusion. In conclusion, narrow sense heritability in a mixed population is best estimated when using a mixture of genetic relationship with races on individuals with at least one first degree relative included in the sample. As you can see the example, there are a mixing of phenotypic variants and the human genetic relationship.